Hi guys, in this presentation I will talk about the magnetism. So let's start. First of all, I will talk about the definition of magnet. A magnet is a material or object that produces a magnetic field. We have many shapes of magnets. In common, we have two shapes. One is bar and the second is horseshoe magnet. Magnets have two ends which called poles. One is the north pole and the other is the south pole. Regarding the magnetic field lines is the path that a north monopole will take if it placed in a magnetic field. For example, if we suppose that we have here magnet, this one north, this one south, and we have north monopole, this one north. Because of the repulsive force between north and north and the attractive force between north and south, the monopole will move like this. Will go away from north and go to the south. So this direction is the same of the line direction. So the direction of magnetic field lines will be from north to south. To understand the properties, first, the magnetic field lines goes from north pole to the south pole. So here the lines is go from north to the south and complete inside the magnet from south to the north. This is the first properties of the magnetic field lines. The second properties is the direction of the magnetic fields is tangent to the field line at any point. For example, if we want to know the direction of magnetic field here, we will follow the direction of the tangent from north to south. Here also we make tangent, so the direction of magnetic field here is the same of the direction of the tangent from north to south. Third properties is the strength of the magnetic fields is proportional to the closeness of the lines. So when we have more tens of lines, this means we have higher magnetic field strength. So between the two poles, we have higher magnetic field than outside. So between the two poles, we have higher magnetic field. Fourth, magnetic field lines cannot be intersect. So, for example, here, this line interact with the two lines, and this one cannot be. This one wrong, because we have intersect between these lines. The magnetic field lines cannot be intersect. Okay. Now, magnetic force. When we have charged particles moving inside magnetic field, this particle will affected by magnetic force. We calculate the magnetic force using this formula, FB equal QVB sine theta. FB means the magnetic force in Newton, Q is the particle charge in Coulomb, V is the particle velocity in meter per second, and B is the magnetic field strength in Tesla. And here theta is the angle between the two vectors, which is the velocity and magnetic field. Now, to know the direction of the magnetic force, we use the right hand rule. In the right hand rule here, the direction of the four fingers represent the direction of magnetic fields. So if this is the direction of magnetic fields, the direction of the four fingers will be the same direction. The direction of the thumb represents the direction of the particle velocity. And here the thumb direction will follow the particle velocity direction. Then the palm of the hand will show us the direction of the magnetic field force. So here, the direction of the force will be perpendicular on the magnetic fields, also on the velocity. It is important to know that we use right hand rule for the positive charge and we use left hand for the negative charge. Or we can just make the opposite side for the positive charge. For example, if the direction of magnetic force for positive charge is to the positive x-axis, the direction of negative charge will be to the negative x-axis, which means the opposite side. Okay, and it is very important to understand what's meant by 3D. Here we have three axes. One is x-axis, which is the first dimension. In the right side is positive, left side is negative. Then we have y-axis. Upward is positive, downward is negative. Then we have the third direction, which is the z-axis, inside and outside. For example, inside the paper and outside the paper. We can express the negative and positive z-axis by dot and cross. Dot is the positive z-axis and x is the negative z-axis. So we can replace positive z with dot and negative z with x. So now let's start to answer some question regarding the magnetic forces. Okay. Example 1. In the following figures, two particles carrying different types of charges entering magnetic fields in different directions. Determine the directions of the magnetic forces acting on the two particles. We have positive particles here and negative particles going to the right side. So we need to determine the direction of the magnetic force when the particles entering the different fields directions. Okay, so let's start by the first one. Here the direction of magnetic fields is to the right. So we put our fingers to the right side and the direction to the velocity also to the right. So here we don't have angle between the velocity and the magnetic fields. The magnetic field's direction, this one, to the right, also the velocity to the right, so theta equals 0. When theta equals 0, the force will equal 0 also. Because as we mentioned before, FB equal QBV sine theta. Sine 0 is 0, so there will be no force in this situation. Okay, this one for the positive charge. For the negative charge, it will be the same. The magnetic field direction to the right, the velocity also to the right, so theta equals 0. So FB will also equal 0 because sine 0 equals 0. Okay, in the second case, the direction of the magnetic fields is to the up and the direction of velocity is to the right. So when we use our right hand, it will be in this direction. So the direction of force will be away, or we can say outside the page. It will be outside the page. So the direction of force will be in positive z direction. This one, the direction of force, which is FB. This will be dot or positive z. Regarding the negative charge, we will take the opposite direction. So it will be x or negative z. This one, dot and positive z for positive charge, and x or negative z for negative charge. Okay, in the third situation, the magnetic field is down and the direction still to the right. So here, for the positive charge, we use the right hand. The magnetic field is down. The velocity is to the right. So the direction of magnetic force will be inside the page. Inside the page, this means X or negative Z. For negative charge, it will be the opposite. So it will be dot or positive Z. For the fourth case, the direction of magnetic field is to the left, and the direction, so this one, the direction of magnetic field to the left, and the direction of velocity is to the right. This one, the velocity. The angle between these two vectors is 180. Sine 180 is 0, so FB will also equal 0 because sine 180 equals 0. So here there will be no force. For the negative also the same angle, so also for negative charge there will be no force. Okay, for the fifth case, the direction of magnetic fields is to the positive z-axis. This one B, positive z-axis. And the direction of the velocity is to the right. So the angle between magnetic fields and velocity is 90 degrees. Now we use our right hand. We follow the direction of magnetic fields by our fingers and the direction of velocity by using our thumb. So the direction of the force will be down in this direction. This one will be FB for the positive charge. For the negative charge, it will be opposite. Opposite mean positive Y. So the direction of FB for positive will be positive Y axis. For negative charge will be negative Y axis. In the sixth case, the direction of magnetic fields is with our fingers, 4 fingers, and the direction of velocity with the thumb. So the direction of force will be positive z-axis, which means outside the page. For the negative charge, it will be inside the page. For the seventh case, the direction of magnetic field will be the direction of the 4 fingers, and the direction of velocity will be the direction of the thumb. So here the direction of force will be inside the page, which is X, while the direction of the negative charge will be outside, which means dot. Okay, last case, the direction of electric field is inside. So we put our 4 fingers inside the page, and the direction of the thumb will be to the right. Then the direction of force will be positive Y axis. So here, this one negative Z, the direction of magnetic field. So this one magnetic field. The direction of velocity will be to the right. The angle between these two vectors is 90 degrees. So the direction of force will be positive Y. This one for positive charge. For negative charge, it will be negative Y. Okay, this one for example 1. Example 2. In the following figure, if you know that the magnetic field strength B is 0.2 Tesla, the speed of the particle V is 20 meters per second, and the mass of the particle is 1 milligram. Find 1. The magnitude and the direction of the magnetic force at the moment when the particle enters the field. Okay. Here we need to calculate the magnetic force. So FB will equal BQV sine theta. B must be in Tesla is 0.2. The Q is the charge, is 5 microcoulomb, so 5 multiplied by 10 power minus 6. V is the velocity. Velocity is 20 meters per second. And the angle between the magnetic field direction and the velocity. The direction of the velocity is positive y, and the direction of magnetic fields is positive z. So the angle between these two axes, which is y and z, is 90 degree. So here we say sine 90 degree, which equal 1. This one equal 1. 0.2 multiplied by 5 is 1. Multiplied by 10 power minus 6. Multiplied by 20. So the answer will be 20 multiplied by 10 power minus 6 Newton. The unit of force is Newton. Now, the direction of force. Because the charge is positive, we use our right hand. The direction of our 4 fingers will be the direction of the magnetic field, and the direction of the thumb will be the direction of velocity. Then the direction of force will be to the right. To the right, this means the particle when enter the magnetic field will go to the right. Then complete a circular path inside the magnetic field. So the direction is to the right. To the right means positive x-axis. 2. The path that the particle takes while it is in the field. The path is circular path, which is clockwise, in the clockwise direction. Okay. 3. The centripetal acceleration of the particle. Here the direction of the magnetic force is changing with time. Is go always to the center of this circle. So we can say that, this one 3, we can say that FB is same of FC. FC means centripetal force, which means in this situation, the magnetic force is same of centripetal force. Okay, from Newton's second law, we know that F equal MA. When we say FC, this means MAC. So here, the AC is the centripetal acceleration. FC is the centripetal force and is the same of the magnetic force. So we can say here 20 multiplied by 10 power minus 6 will equal MA. M is the mass. The mass is 1 milligram. So mass equal 1 milligram, which means 1 multiplied by 10 power minus 3 gram. Now to convert gram to kilogram, this will equal 1 multiplied by 10 power minus 6 kilogram. So here mass equal 1 multiplied by 10 power minus 6 multiplied by AC. We divide both sides by 1 multiplied by 10 power minus 6, 20, 1 multiplied by 10 power minus 6. So this one cancel. So AC will equal 20 divided by 1 is 20. 10 power minus 6 cancel with 10 power minus 6. So the answer will be AC equal 20 meter per second square. So this one, the centripetal acceleration. Now, fourth, we need to find the radius of the particle path. 4. To know the radius, we need to use the AC formula. AC equal V square divided by R. This is the formula that we use to calculate the centripetal acceleration. AC we already find, which is 20. V is the velocity. 20 square mean 400 divided by R. Cross multiply. So 24 equal 400. Divide by 20, divide by 20. So R will equal 0, 0 cancel. 40 divided by 2 is 20 meter. So the radius is 20 meter. Example 3. In the following figure, if you know that the four particles have the same masses and charges, determine the type of the charges. Okay, what we will do here, we will use our right hand and we will deal with object, I mean particles, as positive charges. If the direction of force is the same direction of the movement, then this means the particles is positive. If the direction of force will be in opposite direction with the movement, so it will be negative. So for particle A, the direction of velocity in the beginning will be in this direction. So this one, V. And by using the right hand rule, the direction of magnetic field is outside, the direction of velocity in this direction. So the direction of force will be in this direction. The object is moving clockwise, so the object is following the same direction of force. Because of the FB, the object is moving, or the particle is moving in this direction. So the particle A is positive. I mean, carrying positive charge. Now, for particle B, this is the direction of velocity, and the direction of magnetic field is positive Z. So the direction of force will be in this direction, this one, FB. The object is moving counterclockwise, while the force in other side. So the charge of this particle, I mean the type of the charge of this particle is not positive, so it will be negative. For D, the direction of velocity is in this direction. The direction of magnetic field is to the positive Z, so the direction of force will be in this direction. The object is moving counterclockwise, while the velocity, I mean the force, in other side. So this particle carrying negative charge. For C particle, this is the direction of velocity, and the direction of magnetic field is positive Z. So the direction of force will be in this direction, which is in opposite with the direction of movement. So these particles also have negative charge. So to make it more easy, if the direction of magnetic field is positive Z, which means dot, if we have a particle moving inside the magnetic fields and the direction of movement is clockwise, so the particles carrying positive charge. While if the movement is counterclockwise, so the particle is carrying negative charge. So we already finished part 1. Now regarding part 2, arrange the particles in ascending order according to their velocity. Okay. Ascending mean from low to high. And here in the question, it is mentioned that, okay, it's mentioned that, one second, let me open it again. Okay, it is mentioned that the particles have the same mass and same charges. So to know which one have more or less velocity, high or low velocity, we need to make relation between the radius of curvature and the velocity. So we know that Fc will equal Fb because the direction of force will be always to the center of the circular path. So magnetic force here will be same of centripetal force. This will equal MAC. Okay, FB mean the magnetic force. Magnetic force equal QVB sine theta. So this will equal mv squared divided by r. This is the formula that we use to calculate the AC. Now, the both sides have v, so we cancel v with v squared, then we will have v. So here we will have qb sine theta will be 1 because the angle between velocity and the magnetic is always 90 degrees. Sine 90 is 1, so no need to write sine theta will equal mv divided by r. This one theta, not 0 theta. Okay, we need to find relation between v and r. So by cross product, mv will equal qbr. M is constant because the four particles have the same masses, so m is constant. Q is also constant because the four particles have the same charges. Also, magnetic field is fixed. So now we will have the relation between V and R, which is direct proportional. When V is increasing, R is increasing. So the particles that have the highest radius of the curvature will have the highest velocity. So now we need to arrange the particles ascending. This means from low to high. So B have the lowest curvature radius. So VB is the lowest, then VA, then VD, then VC. So this one, the ascending order from low to high, from low velocity to high velocity. Now, for example, 4. In the following figure, if you know that the four particles have the same speed and charges. Okay, determine the type of the charges. The speed is the same, the charge is the same. Now determine the type of the charges. Okay. Now we can do it manually or we can just follow the rule. Here, the direction of velocity in this direction. So the magnetic field direction is negative z, mean inside the page. And the direction of velocity, as I mentioned here, so the direction of force will be in this direction. This one FB. So this one positive. Now, here, the direction of velocity in this direction, magnetic field inside, so the direction of force will be in this direction, FB. So this one also positive. Here, the direction of velocity in this direction, the direction of force, FB, is this direction. So the direction of force here in opposite direction of movement. So this one will be negative. Here, this one, the direction of velocity. So the direction of force will be in this direction. So this one positive. If we want to follow the rule, so if the direction of magnetic field is negative z and the particles is moving clockwise, so the charge is negative. If the particle is moving counterclockwise, so the type of the charge is positive. which means the opposite of the example 3. Because the direction of magnetic field is opposite, so the rule will be also opposite. Now, after we determine which one is positive and which one is negative, now we go to part 2. Arrange the particles in ascending order according to their mass. Ascending order. So now we need to find relation between R and M, which is the mass. We use the same formula, Fc equal Fb equal MAC. So QVB will equal mv square divided by R. We cancel these two V. So QB will equal mv divided by R. Now we need to find the relation between R and M. So cross multiply, mv will equal QBR. Okay, V here constant. The speed is the same. Charge is the same also. This one constant. The magnetic field strength also the same. So here also the relation between mass and radius is direct proportional, which means if mass is increasing, the radius of the curvature also increasing. Now to arrange the particle in ascending order according to their mass, this means from low to high. So low mean also less curvature. So we will start by A. So MA is less than MC, less than MB, less than D.